Hi, this is Shelby Boyle. My presentation is about nuclear waste disposal. This is for PH 754 Environmental Health and Safety, Professor Jack Caravanos. The purpose of this presentation is actually to define nuclear waste disposal by also understanding what nuclear waste is. We want to highlight current and emerging disposal methods, look at nuclear waste disposal by geographical location, examine trends in quantity of nuclear waste disposal, and present current implications and policies surrounding and possibly implicating and stopping or slowing nuclear waste disposal. This is what we're going to look at. Nuclear waste is the byproduct of nuclear energy. Nuclear energy is used for electricity or for making new technologies. For example, certain types of medical technologies in order to treat diseases. However, in this presentation, we're actually talking about disposal. We're actually talking about disposal as the endpoint for nuclear waste. Storage is not. Storage is an impermanent solution, which sometimes is often confused with disposal. We are also going to talk about the levels of nuclear waste, which are low, intermediate, and high. I'll explain this as we go on. I also wanted to talk about the breakdown of nuclear waste over time. This is important because it's related to how actually nuclear waste is disposed of. So for example, some types of nuclear waste takes millions of years to break down. We're also concerned about the human health effects. As many of us know, it's a prominent feature in today's news. If we can look at the diagram on the bottom, we can see our amount of exposure to nuclear radiation and what its effects are on us. We'll talk about fatality a little bit as well, and other types of exposures, and also what's out there in general in terms of fear and reality. This shows geological disposal of high-level radioactive waste. Notice all of the complexity of the diagram. As we were talking about radioactive waste, I wanted to show actually the policies that are among high-level radioactive waste countries. We're talking about direct disposal, which is in yellow. However, there are other methods and other considerations that take place. So for example, the United States is in red, which means that we currently have direct disposal. However, we are reconsidering that policy. Germany is in purple, for example, reprocessing but also reconsidering possibly for direct disposal. Reprocessing countries are like China and France. Yellow are Finland and Canada. This is a map of the nuclear waste locations in the United States. This isn't about disposal, but I wanted to show you exactly where the locations were in the United States, where nuclear waste is being stored. This is important to understand as from storage, it goes to disposal. So look where we are. Look how many storage sites are around us. And also, look what's being produced around us. And if we draw our attention over to Nevada, over on Yucca Mountain, is actually a site that we'll talk about in a little while about high-level waste. This slide is showing nuclear waste disposal by level in the United States. Notice the top 4 sites. They're all low level. We have one high level, which is Morris operation, and we have one that we're not going to focus on, which is called Waste Isolation Pilot Plant, which is the transuranic level. This actually has to do with nuclear weapons waste. But let's focus back on the top four. Notice actually that we have type of waste. So for example, the top three have A, B, and C. A is the lowest level of radioactivity and C is the highest. Notice Clive only deals with A. It is important also to understand that the United States does not recognize intermediate nuclear waste disposal like high-level international agencies do. Andrews also was opened in 2012 and started accepting waste in 2013. This is the newest site. Low-level waste activity in the United States is really important to look at. The Nuclear Regulatory Commission provides data from 2005 to 2011. What's really interesting about this is that we have 3 sites. So these are all the low-level waste sites, all classes of waste at all the sites. Remember, Clive only looks at Class A. If we look at 2008 forward, Barnwell has a drop-off. And if we look at 2009 forward, we show in Clive and Richland a bit of an increase. This could possibly be related to policies that were going on. President Obama actually stated that more information was needed on nuclear waste disposal. So he commissioned in 2010 a body called Blue Ribbon Committee to actually look on nuclear power and nuclear waste disposal. Their report came out in 2012. This stated that actually we needed more sites for disposal, not less. But if you notice these trends in the data, we see that Barnwell has far exceeded the other 2 sites. Any guesses why? One of the ramifications of policy is that nuclear waste disposal has lost funding. The Yucca Mountain project stopped functioning back in 2014. The federal government did not give money any longer for this area. Many environmental groups, as well as also human health groups, were very concerned about the ramifications of the nuclear waste in this area. Along this mountain ridge, the nuclear waste was disposed of, as normal waste would be. However, this site had had a lot of controversy over a long period of time. And as always, the fear and reality of nuclear waste dumping, even nuclear waste disposal, is alive and well due to the accidents and horrific tragedies that have happened in the past. On the left, we see a 2-headed calf who was unable to stay alive very long. This was due to the nuclear waste dumping in Siberia. We have Chernobyl at the bottom in the Ukraine, and we have a propaganda poster that's really interesting. So to sum up what we talked about, nuclear waste is generated by nuclear power, fission, or technology. Nuclear disposal is different from storage. It's permanent. Geological disposal is the most highly used method in the United States. The U.S. currently favors disposal methods, not reprocessing, even though that might be changing. Low-level waste sites have shown a downward trend in activity since about approximately 2008, since Obama's administration due to policy and potentially funding. No more funding was provided for the Yucca Mountain project. Therefore, only one high-level waste site is left in the U.S. in Illinois, which is Morris. Human health concerns are especially important in nuclear waste because when nuclear waste is not contained, we have seen the effects. Those examples are the Ukraine, Siberia, and Japan, among many. Nuclear waste disposal will continue to be a hot topic for some time to come, and world governments, including the United States, will continue to reevaluate policy or expand nuclear-based technologies as time goes on and as we look at ways to to have long-term sustainability. I mainly looked at the United States Nuclear Regulatory Commission. Also, it was interesting to look at the Office of Budget and Management from the President's Manual in 2009. This helps show some of the implications of policy and what it has on nuclear waste disposal. The Nuclear Energy Institute was also interesting as it helps elucidate some of the policy that we look at. I also examined the Blue Ribbon Commission on Nuclear Future, their report from 2012, which is what President Obama commissioned in 2010. The storage disposal of radioactive waste produced by nuclear power stations is also an important thing, as this is actually a grad student who had come up with this. It's an easy explanation of understanding what nuclear power is and the radioactive waste and how it's disposed.
Thanks.